Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Ryan Hamlin. I'm going to cover a quick type of proof, and we covered this property in a previous video, and I want to prove it for 2x2 matrices, just so you guys can get an idea of like how a direct proof can be done, and really ways to kind of think about proofs when you're trying to figure them out. So if I'm trying to find the determinant of a product is equal to the product of the determinants for 2x2 matrices, a lot of times what I could do, since I'm working with something so small and easy to handle, is I could find, I can give me my arbitrary matrix A, arbitrary matrix B. I can find their product, and then I can find the determinant. And then I can find basically determine the first, determine the second, then I can also find the product of those two things, and just verifying these two things are equal to each other. So let's start out with arbitrary matrices. So let's say matrix A is going to be equal to, say, A, B, C, and D. You're welcome to use subscripts, but since I don't want to go 1, 1, 1, 2, 2, 1, 2, 2, I'd have to write those things over and over again. So really just general letters are going to be easier for me to do and maybe quicker. So then what I want is I need new letters that are not the same as these because I need to be arbitrary because they could be the same, but I don't want to make sure that they look the same. So I'll say E, F, G, and then H. All right, so I have two arbitrary matrices. So we're going to say, A, B, C, D, E, F, G, and H are, say all real numbers. All right, so let's go ahead and do it this way. What I'll do is I'm going to find their let's find their product first, and then their determinant second, and then I'll find their determinant first, and then I'll find their product second. I'll make sure that these things align. So first, what is A times B equal to? So I know that it's going to be, this row times this column, so it's going to be AE plus BG. And then this upper right is going to be, this row second column, so AF times or plus BH. This one is going to be CE, so this row, this column, CE plus DG. And I'm going to take out those parentheses. And then last is going to be this row and then this column, so it's going to be CF plus DH. All right, so now what I can do is I can find the determinant of this product. The determinant of AB is going to be, this main diagonal. This is going to be AE plus BG multiplied by CF plus DH. And then minus, I'm going to have to do this minor diagonal. This is AF plus BH multiplied by CE plus DG. And then we'll multiply these things out. So first is going to be, I'm going to put them in alphabetical order. ACEF. Outside is going to be plus ADEH. Inside's plus BCGF. And then finally last is going to be plus BDGH. And then here I'm going to have minus first ACEF. Outside is going to be plus ADGF, say FG. Inside is going to be plus BCEH, and then finally last is going to be plus BDGH. And actually what we'll notice here is that some of this stuff cancels, that I have ACEF and a minus ACEF, so those are going to go away. And similarly, I have, where are you? Is that it? That ain't it. There we are. Boom. Found you. So this one, and then minus this one. So what we're going to get here is we're going to get ADEH plus BCGF, and then minus ADFG minus BCEH. Now our goal again, so we've found this side. Now our goal is to go in and find this side in the arbitrary and see if we get exactly the same thing back. So what I'll do is I'll start out with, say, the determinant of A over here. Well, AD minus BC, and then say the determinant of B over here. It's going to be EH minus FG. So when I want to find the determinant of A multiplied by the determinant of B, I'm going to have to multiply those things together. So I'm going to have an AD minus BC times an EH minus FG. And first outside, inside last. So we're going to FOIL these. So ADEH outside is going to be a minus ADFG. Inside is going to be a minus BCEH. And then last is going to be a plus a BCFG. And now we're just going to kind of cross our fingers and hope we have exactly the same thing. So let's see. ADEH right there. Plus a BCFG. Boom. Plus minus ADFG. Here we go. And then minus a BCEF. And these are indeed the same. So our proof is done. All right. So yeah, a lot of times we end with like a square say that we finished. We really would like to prove this all the way to any order n, but a lot of times we start with a manageable order so that we can try to get some intuition. So if I can see it works with an order 2, maybe I can find some pattern, and then we'll extend this maybe to an order 3 and see if I see exactly the same pattern. If I see that same pattern, then I can extend this to maybe an order n, then I can prove this into the general. But really the whole idea is let's start out with something small, and then maybe we can expand to something more arbitrary. So if you like the content, please subscribe.